Yeah, welcome to Easy Learning Tutorial class. This is what I have for you today. The question that's on the board, we said a 3 points charge are located at the corner of an equilateral triangle. Calculate the net force on the 7 microfarad and its direction. We are looking at the next force on this man. The force which this man will insert on this and this will insert on this. That's what we mean by next force. So let's move out. We from this solution, let's put solution before we start. From this, I know this man is positive, right? And it shows me it's a positive charge. Look at it. 7.0 microfarad indicate that is what? Positive. There's no negative sign on it. That means it's a positive. Also, I come over to this. I take this. This also positive. Looking at it is a positive. And the second, this one also is positive. And I see that the whole charge is positive. Then now I have here and here and here to be what? Equal. And they gave me here to be 0.6 millimeter. That's what they gave on the question. 0.6 millimeter. Then I have here to be 0.6 millimeter, and here also 0.6 millimeter, and also here to be what? 0.6 millimeter. Okay? That's equilateral triangle. Then here should be what? 60 degree. Here as well should be what? 60 degree. Here should be also 60 degree. That's the properties of equilateral triangle. And QA should be 4 times 10 raised to the power minus 6 Coulomb. That's micro. Then here should be QB should be as well 5 times 10 raised to the power minus 6 Coulomb. And this should be 7 times 10 raised to the power minus 6 Coulomb. You remember, that's it. I've rearranged them in a form which in a microfarad. Then now, what they asked me is the force which this man will insert on this and this man will insert on this. That's the force they asked, or they said the net force on what? 7 microfarad. Now let us look at that. I do this. This is positive. I do this. This is positive. I do this. This is positive as well. And I join them. This is positive. Okay? This man that's 7 microfarad, this is an isolated charge which I'm using this to look for. That's what I mean. The one which is this is an isolated charge, just like a charge that is being lost. Why this man become a text charge which I'm holding in my hand? This one as also is a text charge which I'm holding in my hand. But this man become an isolated charge that been lost. Just like an example, you lost a coin in a sandy sand. You go and get a magneto. Magneto become what? A text charge. While the coin in the sandy soil is a what? An isolated charge which is tantamount to move, is movable. While the one you are holding in your hand cannot move, you only move it. So now, this is my text charge which I'm holding in my hand. This is the one I'm looking for. This is my text charge I'm holding in my hand. This is the charge I'm looking for. So let us look at it. This is QA. I want to see the force which this man will insert on the QC. This is QC. Remember? The charge which this man will insert on QC. If I take this charge, which is positive charge, closer to this man, what will happen? It will repel. Is it not? If I taking this charge, looking for him, coming closer to his field, the field of this man, he will push away. On what direction? He will push away on this direction, which gives me this. That's the direction it will push away. And I call this force a force of A on what? C. This means A on C. Then I'm taking this one as well. When I take this one, I bring it closer to this. What happened? It will what? Push away as well. It will run away as well this way. And I call this force F of what? B on C. Are you getting what I'm talking about? Then looking at this, I have gotten the two forces. I have gotten the two forces. Then now, looking at this, you remember that this is 60 degree, right? This is a straight line. If you look at this, it's a straight line. Then this angle plus this angle is angle on a straight line. This angle plus this give me angle on a straight line, which is 180. That means I'm saying 60 degree plus what? X will give me 180. The reason why? What's the reason? Is a straight line. You get what I'm saying now? Is a straight line what? An angle. So I cannot say that X is equals to 180 minus 60, which gives me 120 degrees. So here is 120 degree angle. Then now, if I know that here is 120 degree angle as well, then if I draw a line this way, what happens? I have a line which is parallel to this man is parallel to this. Then if I do this like this, if I do this like this, what am I going to have? Here is what? 60. Here will also be what? 60 degree. Therefore, here automatically will also be what? 60. Then this to this is a what? 60. The reason why is alternate vertical opposite angle are equal. You know that this angle and this angle, which is A, this angle, which is B, A is equal to what? B. Vertical opposite what? Angle are what? Equal. Then automatically, if I have this, automatically this plus this will give me what? 180. Automatically here will give me what? 60. And this, how I get the forces. So the forces is now, let me put it here. The forces is this way. Look at the forces. Is this way. I have this to be what? F of B on what? C. I have this to be what? F of what? A on C. And this place is what? 60 degree. And the line I draw, which is horizontal line, x-axis, this is what? 60 degree. And also here is what? 60 degree. These two angles are inclined at an angle. You remember what we say? A force, a real force, is only vertical and horizontal. This force up here is a real force. This force acting in what? X-axis is a real force. Force acting in Y-axis is what? A real force. Then, if I push something like this, I'm using the total force to push it. If I push something upward or lift something upward like this, I'm using my total force to what? To do that. But when a force is inclined at an angle, it's no more a real force. When a force is inclined at an angle, it's no more a real force. You have to resolve it horizontally, which is x component of that force and y component of the force. I have to look for x component of this force and y component of it when a force is climbed at an angle. We only do that when the force is climbed at an angle. But when the force is acting on x-axis, that force is a real force. When the force is acting on y-axis, that force is a real force. But when the force is inclined at an angle, we have to resolve it to have its what? Y and x components. Then now, using that application means that we are going to resolve these two forces. We are going to resolve this one to get the y and x components. Yeah, let me start. I started with this one. I have this here. Because of time, I have this. This is my what? F. And I have this. And what is this one? This one is what? F of what? B on C. This is force of B on C. I'm resolving this one. And the angle he has here is what? 60 degree. Then here, this place is what? Y-axis. Do you understand? This means this means this. And this place, I will call this place F of what? B on C, Y. And this one, I will call this side as what? F of B, C on what? X axis. Yeah. If I want to get this, I will not say that what? F of B, C, X is equals to what? F of B, C times cos 60. The other one will be what? F of what? B, C, Y is equals to F, B, C times sine 60. Somebody will say how? If I say opposite over hypotenuse, that gives me what? Cos. Opposite, this side, which is this line, over hypotenuse. What's this line? FBCX over hypotenuse equals to cos. And when you make it subject of our, can I write it down to say this? Look at what I'm talking about. This x all over what? FBC equals to cos 60 over 1. Cross multiplication. If you cross multiply, if you have this one, the subject of it. If you cross multiply this, you will have this. So that's what we're talking about. That's how I did it. And that's how you would also do this one. This one now, I said sine 60 become opposite over hypotenuse. Opposite over hypotenuse, which give me what? Sine. Then cross multiplication will give me this. This is my opposite with vertical. Then I have resolved this. I have resolved it. Can I clear this? I have resolved this to what? When I resolve it, what I am having here will be what? A force that move. Can you see what I'm talking about? A force that move this way and this way. Look at it. What I'm going to have now, F, B, C, X. And I'm going to have, again, F, B, C, Y. That's this man is this man is this. Look at it, it's moving. Just watch me. If I'm resolving this force horizontally, look at it. Look at its direction. If I'm resolving this force vertically, look at its direction. Then I'm going to resolve. I'll finish with that one. I'm going to resolve this one, this particular force. I'm going to resolve it. And we have what we have here. Can you see what I'm trying to do here? Watch. Look at the force. Look at the force. Look at it here. And it has this. Can you see what I'm doing? It has this. And this place is my what? Y axis. I call it what? F of what? A on what? C, Y. And this one here, I call it F of A on C, X. And this man is what? A on what? C, which you know. Look at it. A on C, which you know, which we have done. Now, you see the angle, which is 60. We made an angle of what? 60. Can we compare here? Then I'm going to resolve it the same way I did what I have here. Resolving it, I will have that F A on CX is equals to what? F A on C times cos 60, just as we did here. Then this one will be F A on C Y is equals to F A on C times what? Sine 60. Just as what we did here. Opposite over hypotenuse, sine, adjacent over hypotenuse is what? Cos. Then I have resolved it. And when I resolve it, what I'm going to have as this force, look at its direction. If I resolve this one vertically, it will move the same way like this, right? Look at what it will move the same way like this. And when I resolve this man, it will move this way. And take carefully what I'm talking about. When I resolve this man horizontally, if I take this horizontally, look at its direction. Vertically, look at its direction. Are you following what I'm talking about? Horizontally, look at its direction. Vertically, look at its direction. So this man become F of what? A, C, Y. This become F, A, C, X. We are done. Then now, these two forces, if we now bring them together, I hear what I'm saying now. If we bring them together, what I'm going to do now, if we bring them together, we have this. Look at it. And this one for this, that's give me F, A, C, Y, F, A, C, X. The other man, this way, which give me this way, which give me F, B, C, X, and F, B, C, Y. Look at it. And look at the two forces that is acting on this man. That's the two forces that is acting on this man. And that two forces is what we have resolved now. Then if you look at this man and this man, these are moving this way, and this man is moving this way. What will happen? You what? Subtract. The two forces are moving in the horizontal, while in the opposite direction we subtract. While these and these are moving in the same direction, we'll add them together. So the total, what I'm going to have will be this. Watch what I'm going to write here. The total of what I'm going to have will be this. I'm seeing that this man depends on the one that is greater than each other. Before then, let me calculate and know the one that is greater than each other before I cannot know the direction which it will be. Then for this, it implied that I needed force of A on C. And I needed force of what? B on C. Are you get what I'm saying that? I needed force of A on C. And I needed the force of B on C. Then let us look for it. I'm going to say force of what? A on C is equals to QA times QC all over R squared. You get me? Where R is given to me as 0.6 millimeter. And I'm going to convert this to what? To meter by saying 0.6 divided by 1,000. And that gives me 0.006 meter. Why did I convert it to meter? K. This K is measured in meter per force. Meter per force. That's the unit. So therefore I have to convert this to meter. Then substituting the value, I have that FA on C is equals to 9 times 10 raised to power 9 times 10 raised to power 9 for K times my A. The value of my A is 4 times 10 raised to power 4 times 10 raised to power minus 6. The value of my C is 7 times 10 raised to power minus 6 divided by what? 0.0006 all what? Square. All square. Divided by 0.006 all square. When you use your calculator to punch this, I've told you how to use your calculator to do this. You just open the bracket. Have you opened bracket in your calculator? Press 9, press shift, press log, press 9, times again, 4, press shift, press log, press minus 6, times again, press 7, press shift, press log, press minus 6, close the bracket. What I mean by closing the bracket, you do like this, divide, you open again. When you open again, you type what? 0.0006, then close. You will see something like this in your calculator, you press it, it will give you what? Square. Then when you press equals to, you will have what I'm going to write now. When you press equals to, you are going to have this. F of A, you will have 700,000 Newton. I get what I'm saying. I will now look for what? F of B on C, which is equals to what? K as well. Q, B, Q, C, all over what? R squared. That's imply I'm going to what? Clear this. You have seen this. This, what I did here. You don't need this in your exam. You don't need this. You don't need writing all this and resolving this. What you needed in the exam is this fact. These two things I have done here and these two things I have done here. Are you following what I'm talking about? When you are writing your exam, you don't need all this resolve I did here. What I'm doing here is for you to understand the proper, how the thing come about. But writing exam, what you needed is just to know this. You just draw this. You draw the forces. Are you get what I'm saying? Now, immediately you have drawn the forces. You resolve it. Resolving it is stating this, because you have known that what cos times what this is giving me for x-axis, and sine times this is giving me for what y-axis. You have known it. Really, you have done it. This is the only thing you needed to do. All these ones is for me to give you a clue, a balance of what happened. So let me clear this. I'm clearing it. So for that, we have seen how the force is being resolved. Let's see the major thing we needed. That gives me what? F of B on what C will give me 9 times 10 raised to the power 9 times what's my B? My B is given to me as 5 times 10 raised to the power minus 6. And what is my what? C. My C remains 7 times 10 raised to the power minus 6 divided. What is my distance of separation? Is 0.0006 because it's a what? Equilateral triangle. The all sides are what? Equal. The sides are equal and the angle are what? Equal. Therefore, when you press this in your calculator, according to what I explained to you here, you have 87500 Newton. That's what you have here. Then that's the major thing I needed, these two things. I will now start to what? Find my what? A, C, X. That gives me F FAC times cos 60. And what is this man? I've calculated it to be what? 7,000, which is 700,000 Newton times cos 60. When you multiply this with your calculator, when you do this in your calculator, you are going to have 3500. Oh, this cannot enter here. Let me put it here. FACX will give me 350000 Newton. That's 350,000. Then now, I'm looking for what again? FA on CY, which give me FA on C times sine 60. I think you're following. FA on CY is what? Equals to FA on C times sine 60. Then when I put it, what am I going to put? 700,000 times sine 60. When you punch it in your calculator, you are going to have 6217.8 Newton. 0.8 Newton. That's what you're going to see here. Let us also clean this place for clarification to carry it properly. Then when you get this, I am going to have again, I'm going to calculate for what? F of B on C X, which give me F of what? B on C times cos 60. Give me cos what? 60. That's it. Cos what? 60. Then when you do that, you substitute for the value. I have FB to be 500,000 times what? Cos 60 degree. And when you do that, you have B on CX to be, when you calculate it, it will give you 437,500N. That's what it's going to give you. Then you look also for FB on CY, which will give you FB on C times sine 60 degree. And when you substitute the value, when you have also 875,000 times sine 60 degree. And that will give me that my FB on C, X axis and Y axis is equals to, if you use your calculator, you will have what we call 75777.2 Newton. So we have gotten all we needed. Now let's go in. You remember what I drew before? Can I clean this? Have you observed this? Can I clean this? Yeah, I can clean that so that we have the space as well to run it all. This is what we needed now. So look at what we are talking about. We run it all. You remember what I said? That this force, this man goes this way, this man goes this way. These two will be added together, and these two will be subtracted. And which one that goes this way? The one that goes this way, is FB, there's a FB on C, this man that goes this way. And this one that goes this way is FB on what? X. So what am I going to do? I will not say that what? My resultant force will move this way. What's that? What it means. Look at how the thing will be. This means FB on C X minus FB of F what? A on what? C X. This place will be what? FB on C Y plus FB on C X FA on what? C Y. Let's add them. This one is adding. The two forces are moving the same direction. Look at them moving the same direction. We'll add them together. why this and this are moving, this one moving this way, this one are moving this way. Then why is it moving this way? The resultant, because this one is greater than this, so it will move on it. Just like when two of us are pushing ourselves, I have energy of 20, you have 19. What happened? I will use extra one that I have greater than you to push against you, and I begin to move in this direction. So you will also move in my direction. So this is what happened here. These two forces are moving in different directions. So these are bigger. Subtract this, it will move in its own direction. And what does it give me? When you subtract it, what we are going to have, when you subtract this and this, can we look at them? I have this. Watch what I'm going to do here. Watch what I'm going to do here. Then this become, where is my y? If you add this man, which is FBCY, look at it here. Then add FACY, look at it here. Add them together. It's the people that are moving on the y-axis upward. Add it. What you are going to have is what? 1, 3, 6, 3, 9, 9, 0. When you add, what are you adding? Add this for y, this for y. I get what I'm saying, that? Force of A on C along y-axis. Force of B on C along y-axis. I add them together because they are moving in the same direction. Then this one should be this man. What is the x-axis? Look at it. This man minus this man. Look at FAC x-axis, FBC x-axis. This is bigger than this minus this. Will give you 8, 7, 5, 0, 0. This is how I get it. Then when we have gotten this, I think you remember what I said. This how I get this is what? FBCX minus FACX will give me this. Why this one is FBCY plus FBC FAB FACY. Added it together. Look at I've written it here. You can see where I made it clear to you. This is Y, CYB, Y. This is what? ACY. Look at it. This subtraction is FBX minus this. I think it's clear. Then that comes to resultant force. What is the resultant force? Resultant force is force that cancel the effect of as many as what? Force that is acting on the body. Resultant force is the force that cancel the effect. What is the resultant force? Look at it here. I'm drawing it. Are you following? Look at my resultant force. And what we call FC. Why did I call it FC? It's a force on C. That's the resultant force. This resultant force is a force on C. After all these people, the result of C is a what? Resultant force. And how do I get it? I will get it by Pythagorean theory. You know Pythagorean theory, opposite square, adjacent square is equals to what? Hypotenuse what square. I can now say that FC square is equals to 87500 square plus 1363990 square. Then let us clear it here. Can I clean this place right now to make it clear for you? Let us clear this place now. We have seen the question. Let us clear this place and make it clear. Final answer here. Then I will have this as my final answer, which is what? FC, making it subject of formula become a square root of 87500 all square. Look at it here. And plus, we have what? 1363990 all what? Square. If you press this in your calculator, you will have FC equals to what? 1366793.9 Newton. That's the answer of what they actually the net force. This is what we call net force. Net force, which is called resultant force. Either you call it net force or resultant force. Then the next question is asking us the angle. They said what? Direction, the magnitude. They said what? The net force and the each what? Direction. Each direction. Can we come over here? Look at each direction. The direction of resultant force is always the angle which he made with what? With x-axis. The resultant force, the direction of resultant force is always the angle which he made with what? X-axis. And that angle he made with x-axis is phi. Look at it. This angle he made with what? X-axis. And how did I calculate this angle? I said what? Adjacent, opposite over adjacent. It's not tan, my people. Opposite this side over adjacent is tan. I can now say tan phi is equals to opposite. What's the opposite? Opposite is what? 1363990 over adjacent. What's adjacent? 87500. And when I do that, I will have this. When you divide that, you will have what? 15.5885. That's what you have. Then for me to get the phi, I will now say phi is equals to tan inverse of 15.5885. Therefore, phi will be equals to 86.3 degree. And that's the direction of the force. Is the direction of the resultant force. Direction of the resultant force. That's the direction. And the magnitude of the resultant force is this. Its direction is this. I get what I'm talking about. The magnitude is this, and its direction is this. You remember what I said? All this diagram I was using to illustrate how to resolve a force. It's not necessary while you are writing an exam. What you needed that is necessary while you are writing an exam is to know that a force inclined at an angle must be resolved horizontally and vertically. And horizontally of it is a cos times that force. Then vertically is sine times that force. Are you getting what I'm saying now? That's the only thing you needed. That a force inclined at an angle, horizontal, which we call the x component of it, is that force times cos of the angle you made with the horizontal. Then for vertical, that force times sine, which the angle you made with horizontal. That's the only thing you needed. Then you have resolved that force. You now know the direction. But while you are resolving it, you know the direction. Just as this one is now. As I'm resolving it, I know that this is I'm getting. This is cos. I'm getting this is sine. Cos times the angle. Then sine times the angle. That's all for y-axis. If you know this, that's all you needed to know. The only thing you have to do is to do what I did here by knowing that this is a text charge. This is a text charge. The one they said the resultant force on him, the one they asked us to calculate the resultant force on him is the one that is isolated. While the one that is acting on it is called a text charge. You just know it. That when those text charges, one you hold in your hand, you use it to come closer to it. You know whether it will attract. If it is opposite side, it will attract a magnet. If it is the same charge, it will repulse, as we see here, because all these one are is the same charge, so they repulse. Know it. This is the better thing. You have to know how the force goes here and how to resolve the force. That's all. You now come back and do this. That's all. You substitute the value and do this and resolve the force. Use the Pythagorean theory to get the resultant. I think I made it clear to you. So you have seen that resolving forces horizontally, which is x-axis, is all about cos and that's force. And resolving it vertically is all about sine and that force. So if you love what we are doing in this class, please subscribe, share, comment. Are you getting what I'm saying? Please subscribe, share, and comment if you love what we are doing in this class, which you call Easy Learning Tutorial Class YouTube. Thank you.